Hello, everyone. My name is Ivan. And today, I'm not going to tell you how to run an LLM on your Cortex M0 sensor device. I'm not going to tell you how to use ChatGPT to do everything in your industrial facility. But instead, I'm going to tell you how to combine the power of the LLMs and all these technologies that are talked about in the last years with the IoT to extract value from all this data that everyone's talking about here today. All the sensors are consuming all this data, and 99% of the data that is out there gets lost and no value is getting extracted of it. But first, before going to the LLMs and ChatGPTs and whatnot, let's take a step back and kind of understand what the world around us looks like. So there is light, there is sound, there is smell. All these signals are coming in, and our body has sensors. So whenever I smell something, I can tell whether it's French fries or a burger. Whenever I hear something, I can tell it's rock music or rap music. So what happens when we do this is our brain is inferring the signal to do a classification or some sort of prediction of what's happening. So the same thing we want to do with the sensors that we are deploying in the facilities or everywhere else. We want our sensors to look at the data and tell us what's going on. So traditionally, how this is done, and how I think most of us have been doing it so far, is looking at what we want to do, saying, OK, I want to detect when my temperature is going over 10 degrees. So I'll program a rule, and then after it, I'll get an outcome out of the rule I've set manually. But with the new approach, which is AI, we don't need to set the rules ourselves, but instead, we can give the algorithm all the data that we anticipate to see, and the algorithm will set the rules itself. So this is very interesting because in both of the approaches, the traditional heuristical programming and the AI, data is paramount and starts at the beginning of everything. But we're going to talk about it later in more detail. So what are the downsides of the traditional approach or the heuristical programming? Well, the real world is really fuzzy, right? So we can say we want the temperature not to cross 10 degrees, but in fact, when I'm building some program that I want to detect some defects, I know there is one defect I'm accounting for, but sometimes every other defect is different. So if I set my accelerometer thresholds not to cross something, but another defect will not cross my threshold. So, well, it's still a defect. So that's why it's very labor-intensive to kind of understand how all this data is working and what we want to extract from it. So we need to do and measure and adjust each number manually to see that all the cases are covered. And lastly, the insights are being left on the table. So all the data that we receive is very, very rich. So if we are looking at one problem and say we solved it, but there are so many other problems that can be solved with the same data, we just don't know how to extract this value because this threshold is not so apparent to be set. Well, what do we do and how do we do AI with all the sensor data? Here is Edge Impulse, the platform that we provide that helps you build edge AI pipelines and run them on edge devices directly. So how this works is basically you construct an inference pipeline and create it in the platform. You train the models and everything, and you deploy them to run on all sorts of devices. So this presentation is not so much about how to run this in general, but overall, this is very, very simple. We take the data, we create a pre-processing algorithm that lets us extract and reduce the dimensionality of our data. We create a simple model, and we do an output. These models that are put on edge devices are typically very, very constrained. They're built to solve your particular problem. And that's how they differ from, for example, the LLMs that are built to kind of do everything at once. And the next question comes to this. So where can I deploy? So this is a schematic that kind of shows that there's a lot of different classes of devices. You can deploy it on Linux devices. You can deploy it on MCUs. You can deploy it on NPUs. And anything that has a CU, a PU in the end, you can deploy it to. So how our CTO likes to say, we run on anything under the sun. I think that's the best answer you can get. So the benefits of edge AI that we typically explain happen to interfere or share a lot with benefits of IoT in general. So the cost of using edge AI and IoT reduces a lot of the costs because all the left box is actually related to the cost, because we're saving power, we're saving bandwidth, because we don't need to send all the raw data up in the cloud for processing. We can do the processing and all the intelligence directly on device. That's how it actually matches with LoRa very, very much, because there we can process all the data right on the device and use one small messages of extremely low power radio technology just to deliver the final result. And what's interesting, I think, of course, the privacy is increased a lot, because the data never leaves the premise or device. The data never leaves your factory, your hospital, whatnot. But I think what's very interesting is that now with Edge AI, you can extend the possibilities of what kind of devices you can even use with technologies like LoRa. For example, the camera that's now on the slide. Like before, to do something with camera streaming, the bandwidth of LoRaWAN would not allow you to just send the frames and do some processing in the cloud. But what you can do now is do all the processing on this camera in 720p resolution and do all the object detections and classifications and what you want right there, and use LoRaWAN on this camera to send the devices up to wherever you want your results to be. Okay, so now we have kind of leveled up, but whatever I was saying right now, everyone knew already for the last 5 years, I believe. I think some of you might have seen the famous sheep presentation a few years ago on the other stage, where Edge Impulse was introduced. So we've been doing this for the past 5 years already. We've been putting Edge AI intelligence on sensor devices and making them way smarter. But let's revisit the most important thing of any machine learning application, not just edge machine learning. It's the data. Everything starts with data. And a few interesting things were going on with data in the last couple of years. Gen AI and LLMs. So it's a love and hate for everyone. Everyone skips reading posts that mention Gen AI already. But if you think about it, it's incredibly powerful tool that you can do so many things with. So I literally just prompted this, and most of you have used DALL-E already to generate synthetic images. We have this cartoony image, but it delivers the message that I want to do. But there are also models that can generate photorealistic images with exactly the same prompt. So what this means is now I can create data that I don't have for a use case that I want to build, but I don't have the data yet. But I can use these models to create a data set for myself and make my devices smarter without having to collect it myself. So what we've done in Edge Impulse, now we have integrations with synthetic data sources. And that's not only related to images, but it's a multi-modal input. In fact, you can use any model that generates sound, voice, and image to augment your data set. For example, here, it's an integration with OpenAI Whisper that generates keywords.
The Things Conference. The Things Conference.
So without having to touch a microphone, I can create a data set that will allow me to train a model that will detect when I say the Things Conference or Hey Alexa on my phone. I don't have to say this word any single time. These models are incredibly good already. Another way is the 11 Labs model that generates synthetic sound, but non-voice audio. So if I want to build a model that detects glass-breaking impact, I don't want to take a truck of glass and break it one by one to record my samples. Instead, I would run this model and generate these samples. So now, again, I don't have to collect this data myself. These models are already very, very good at generating this kind of data. So that was one method of creating synthetic data using generative models. So this is, you could say, kind of fake and generic. And another way to do this, and recently we integrated with NVIDIA Omniverse. So this is a tool that allows you to create 3D digital twins of whatever you like, including, for example, your factory facility, your production line, or your smart meters, or whatnot. And then, using these scenes, you can generate an enormous amount of kind of frames or images that are specific to the digital twin of what you're trying to do. So now, in this production line with Pepsi, I can actually run the camera around from any angle I like, with any lighting conditions I like, to kind of make my data set and model more rigid. And this is an example of an actual use case we did with one of the customers. So they have modeled their warehouse with pallet trucks, and the use case was to do a model that detects pallets and counts them. So instead of going around with a camera and filming things, they modeled this and scripted the camera to go through and label the data set. Another interesting way, the NVIDIA ISAC, it's an actual physics simulator where this use case now demonstrates how we can collect a data set of people falling. So a very common use case is fall detection based on accelerometer data. Now again, instead of falling with a device on my hand, I can run this and I will have a quite rigid data set that will tell me if this use case is feasible or not. No one has to be injured to create this. Right, so this is great. Now we know that we can actually collect a lot of data without having to collect the data. But what's important, often missed, is that everything starts with actually labeled data. Not any data is good. In fact, if you have a lot of bad quality data, that will damage you, that will make you waste time, and your model will perform worse. So how can we increase the quality of our data set? Going back to LLMs again. So now the ChatGPT, for example, is a multimodal input where I can put an image and ask it what's going on. So this image is actually a screenshot from recent Olympics where a Dutch rowing team, I believe, got the medal. And in fact, you can look at the answer, and it's incredible that this model just could look at it and not only say there is a person in orange, but assume that it's a Dutch national team at an Olympics competition connected with a water sport. It's crazy what this can do. Sadly, this is not something we can use in IoT, because even if we wanted to hook up our camera devices and sensor deployments and send the images to ChatGPT to ask it what's going on, it's incredibly expensive to do this, because one, again, the bandwidth is the most expensive part of any network. Second, the inference of ChatGPT itself, you can see the calculation there. If I were to do this with 1 FPS at 512 by 512 input, I would spend $172 per day just for the compute of ChatGPT. This is not sustainable. And the latency, of course, is very long. Well, what we can do is use the incredible knowledge of these models that are, by the way, zero-shot, which means that you don't have to tell it in advance about what you want to do. You don't have to give it examples of your data so it learns how to interpret it. It already knows. I will give it an image and ask it, is the person wearing a hard hat or not? It didn't see my images before. It will tell me. So this is how it looks in the platform right now. So for example, I would already have a data set of unlabeled images. Before, I would have to go manually over all these images and label them, but now I can ask ChatGPT or any other LLM to do it for me, and the quality sometimes will be better than any other automatic tools that would be used for this purpose. Right, so this is kind of what it looks like, what we've talked about until now. We have foundational models, big models that run in the cloud that are really, really good for general use cases, that they can do everything, but perhaps they cannot do things that exactly you need to do at exactly your warehouse with your lighting conditions, and they're very expensive and bulky to use. On the other hand, we have domain-specific models that we can develop just for our edge devices with just our data. They'll be extremely tiny and fit everywhere, and this requires domain expertise, but it's very hard to collect data for it, and good quality data. Another way we can combine these two streams without having to label our data, but actually use this during the inference time, is being a little bit smart about how and when we use those ChatGPTs and all these remote APIs that give us the results about who won the rowing medal. So what we can do is we can train a model that would run on device that does a simpler task, more general task. Say, is there an anomaly on the floor? I can give the model that will run on my tiny device frames of empty floor and tell it this is the norm. Everything else that will be on the floor is an anomaly and mark it. This is very simple to do, and these models run at 60 FPS on microcontroller-grade devices. But then, whenever any anomaly will appear, we will take just that image and send it up to ChatGPT. Now, instead of sending 30 images per second or even 1 image per second, I will only send this expensive request once, and I will get a precise answer of what's going on. If I were to train a model that would run on the device and tell me what is going on, I wouldn't be able to do it now. Honestly, that's not possible. So here's a demo, a recorded demo that actually shows how to do it. This model now is doing the anomaly detection. On the right, you will see what's going on. So now the cascade is disabled. Now, while it's enabled, whenever there's an anomaly, each of these frames gets sent to GPT, and GPT responds with what's going on in the image. But when there's no anomaly, nothing gets sent. I'm not wasting my bandwidth, and the model is running just on the device. Now we're putting the beer bottles, the signature prop of Edge Impulse demos. And when the bottles are there, I'm actually getting not just that something is on the floor, but I have 2 beer bottles right there. So this is incredibly smart way to take the most out of the both worlds, because there's no one size fits all. We cannot run LLMs on microcontroller device. Even if we can, they will never be as good and capable than the ones that are run on the data centers and huge beefy GPUs. So why not we just combine them and take the best out of both worlds? So again, Edge AI and IoT look like it's a match made in heaven. Well, in fact, the cloud AI can also be in this equation. And if we are smart about how we build our solutions, we can build incredibly smart things and all be happy about how cool it all works. So the last thing we always like to show is that we actually have a book about AI at the edge that's written by our head of ML, Dan, and our DevRel engineer, Jenny, who's sitting somewhere there. So you can scan this QR code and get a free ebook. And if you go to our booth C08, you can actually get a hard copy and check out all the cool stuff that we've done around this topic and other topics on our YouTube channel. Thank you very much. And yeah, see you at booth C08. Thank you.